Bismillahirrahmanirrahim. This video is going to explain the role of adenosine triphosphate in interaction of myosin with actin during skeletal muscle contraction. Before watching this video, you must watch my video on sarcomere describing sliding filament model of contraction. The link of that video is available in the description. Let's start if you have already watched that video. According to the sliding filament model, myosin heads pull the actin at the binding sites. After that, myosin heads detach, recork, reattach to more binding sites, and repeat the cycle again. This repeated movement is known as the cross-bridge cycle. The motion of the myosin heads is similar to the oars when an individual rows a boat. The paddle of oars pull are lifted from the water, repositioned, and then immersed again to pull. Each cycle requires energy. The action of the myosin heads in the sarcomeres repetitively pulling on the actin filaments requires energy which is provided by adenosine triphosphate. The first step in the cross-bridge cycle is for calcium to bind to the troponin so that tropomyosin can slide away from the binding sites on the actin strands. This exposes binding sites on the actin. Cross-bridge formation occurs when the myosin head attaches to the actin while adenosine diphosphate and inorganic phosphate are still bound to the myosin. Inorganic phosphate is then released, causing the myosin to form a stronger attachment to the actin. This enables the myosin head to move toward the M line, pulling the actin along with it. This movement is called the power stroke, as movement of the thin filament occurs at this step. Adenosine diphosphate is also released after the power stroke. In the absence of ATP, the myosin head will not detach from actin. This stage is sometimes called as the Rigor stage. ATP binding causes the myosin head to detach from the actin. After this occurs, adenosine triphosphate is converted into adenosine diphosphate and inorganic phosphate by the intrinsic ATPase activity of the myosin head. The energy released during ATP hydrolysis changes the angle of the myosin head into a cocked position. The myosin head is now in position for further movement. When the myosin head is cocked, myosin is in a high energy configuration. This energy is utilized as the myosin head moves through the power stroke. At the end of the power stroke, the myosin head is in a low energy position. After the power stroke, adenosine diphosphate is released. However, the formed cross bridge is still in place and actin and myosin are bound together. As long as ATP is available, it readily attaches to myosin, the cross bridge cycle can recur, and muscle contraction can continue. To keep skeletal muscles working, a great amount of ATP molecules are needed. When a person dies, there are no ATP molecules available for myosin heads to detach from the actin binding sites. So the cross bridges stay in place, causing the rigidity in the skeletal muscles. This rigidity is called the rigor mortis. Thanks for watching and listening. Do share this video with your friends and colleagues. If you like this video, subscribe to this channel for watching more videos.